Welcome to the last example for solving trig equations review. Here we are with problem number 7, so let's go ahead and finish this one up. Now here in problem 7, it says solve the equation in the interval 0 to 2 pi, and we're presented with cosine of 5x cosine x plus sine of 5x sine of x equals square root of 2 over 2. Now this was really similar to a problem that many of my students had on a quiz and had a really difficult time with. What you've got to do is recognize that this is a sum or difference formula. The 5x, that's the same as alpha, and the x is the same thing as beta. Your book might use something different than alpha and beta. It might use u and v or any two other variables for the formula. Now the correct formula is cosine of alpha minus beta, or in this case cosine of 5x minus x. Simplifying, we get cosine of 4x equals square root of 2 over 2. Now we've got to think about the unit circle. There are two spots on the unit circle where cosine is square root of 2 over 2. So just ignore the 4x part for a second and think about those two spots. One is going to be at pi over 4 and the other is at 7 pi over 4. All right, from here, what we're going to do is take 4x, our angle, and we're going to set that each one of our values. We're going to have 4x equals pi over 4 plus 2 pi k. Again, k is an element of the set of integers, which is denoted by k, the little element symbol, and then z. And then we're going to take 4x equal to 7 pi over 4 plus 2 pi k, with k an element of the set of integers. I've got to get the x by itself, which means I've got to divide everything by 4. When you do that, that gives you this mess right here. What I like to do, and this is just my personal thing here to make it easier for me, I get a common denominator. That way it's easier to add things together when we're dealing with fractions. So when we substitute k as 0, that's pretty straightforward. We'll just have our two values, pi over 16 and 7 pi over 16. When we put in 1, we'll end up with the two values of 9 pi over 16 and 15 pi over 16. When we substitute 2 for k, we get another two values, 17 pi over 16 and 23 pi over 16. Again, this is just a lot of arithmetic at this point. There's nothing really difficult about it. But what you want to kind of do as you start putting numbers in, you want to think about, all right, what value is going to be more than 2 pi? Now, since we have 16 in our denominator, so I'm just going to kind of write this over up in the upper corner here. 2 pi is the same thing as 32 pi over 16. So if I get to anything 32 pi or higher, then I just ignore it, which if we look at our last two pieces down here, 35 pi over 16 and 39 pi over 16, both of those are more than 32 pi over 16, so I don't have to go any further. I am done. Now, of course, you want to write all of your answers in numerical order, so that would give you the following list of solutions. But take your time, and it's really complex because you've got to recognize that it's going to be a cosine difference formula to get you started. All right, so that's it for our last example, number 7 on our review for this. So hopefully you've got all of this down and you'll have no problem, and you guys are going to rock out on your next chapter test. All right, thanks for watching, and I'll catch up with you guys soon. Peace out.